Alright class, in this lesson we're going to take a look at our solving exponential equations. Now, previously we've solved log equations by making them exponential. Here we're going to be taking our exponential equations and making them logs. And we do that with our circle pattern, where we start with our base and we write log of our base. Well, the base is the thing that's being raised to a power, which is 7, so we write log base 7. And then we use our circle pattern, other side equal sign, so log base 7 of 20. And then we go to the final last thing that's left over, and we say this is equal to 3x. Okay, so if you've forgotten this is like the very first lesson on logs. I did the circle pattern, so we go back to that to reference, but log base 7 of 20 equals 3x. So we've almost got our final solution. We're just going to have to divide by 3. Well, before I do that, I actually want to take my calculator and get a decimal approximation of what log base 7 of 20 is. And in the previous lesson we learned about change of base formula. To plug this in my calculator, I just put a line there and put log on the bottom. And so now on my calculator I can actually just do log of 20 divided by log of 7. And if I type that into my calculator, I should end up with 1.5395. Okay? So basically 3x is equal to 1.5395, but we want x alone, so all you have to do from there is divide by 3. And so we just take our answer on a calculator and just go ahead and push divided by 3. And if I do that, I should get x equals 0.513, you can round it to 2, okay? 0.5132 should be what you end up getting. And now we could check it. We could actually take back in the original problem and try this out and raise 7 to the 3 times 0.5132 power. And if I do that on my calculator, because I rounded, I'll actually end up with 20.0038. So I'm really close to 20. It's just that I rounded, but this is the actual answer, and it's just fine for x. Okay. So we're going to go ahead and do the same thing with this next problem. It's just a little bit more work because I've got x plus 4. So I change this exponential equation into a log by writing log base 3. So I start with a 3 of 101 equals x plus 4. Okay, and so I can go ahead and take my change of base formula and do log of 101, and then it's base 3, so I just draw my line and put log on the bottom. And now I take my calculator and go ahead and do this. So log 101 divided by my log 3 should give me 4.2 and then 008, but 4.2 is close enough. And that's equal to x plus 4. Okay, so now to finish, all I have to do is subtract 4, and I should end up with x equals 0.2. Is my answer for x. Okay, so it's not working out too badly as long as we can do our converting to logs and then doing my change of base formula so that I can actually use my calculator. Okay, well, let's do some more of these logging problems. And on this first one, I'm going to do the same thing. I've got log base 25, so I start with the base of 15 equals 2x plus 1. So now I just change my base, so put over a log, and now I can go ahead and type this into my calculator and turn it into a decimal, because I don't need to leave it as a log. Let's turn it into a decimal. And that, if I plug it in properly, should give me 0.8413, and that's equal to 2x plus 1. So from here it's just simple algebra where I just subtract 1, and that should give me negative 0.1587, and then that's still equal to 2x, so then I just take that and divide by 2, and I should get my final answer of x equals negative 0.0793. Okay? So now we're going to take a look at one that has an e, so it's just a little bit different. And so I write log base e of 12 equals 2 minus x. Now at this point we're supposed to recall that log base e is actually ln. So I can actually rewrite this whole thing to be ln of 12 equals 2 minus x. So now I don't have to do any weird thing of changing base on my calculator. I can actually type in ln 12. So if I type in ln 12, I should end up with 2.485, and that's equal to 2 minus x. So my algebra skills should tell me to subtract 2, and I should end up with, box that out there, we should end up with 0.485 equals negative x. So that means that x, if I change the sign, positive x will equal negative 0.485 as my final answer there. So now we're going to get even more complicated. Now this time, both sides have bases. And so I said when you do your log, you're supposed to pick the one that's being raised to a power. Well, they're both being raised to a power. Well, we could pick either side, but since we've been working with the left side so far, let's keep working with the left side and call this my base. So I'm going to write log base 3 of 4. Now here's the thing, it's of 4 to the x plus 5 power equals x plus 2. And if I do that, then I have to take this x plus 5 and put it out in front, like this. Okay? Because, remember, if we have exponents, they're supposed to be able to move out in front. And I can't do the change of base formula until I actually make that out in front and rewrite this as my x plus 5 times log base 3 of 4, and that's equal to x plus 2. Now that I've rewritten it like this, all I have to do is take my calculator and just put log on the bottom, and I can take this and turn it into a decimal. Okay? And if I do that, this fraction turns into 1.261. And so basically what I'm going to do is I'm actually going to erase this log part and just rewrite this 1.216 right here. 261, sorry, because I want you to see that really it's right next to this x plus 5, which means I'm going to end up needing to distribute it right there. So let's write it up top. I've got 1.261 times x plus 5 equals x plus 2. So now I need to distribute in here, and I get 1.261 x plus whatever 5 times that is, and that should give me 6.305, and that's still equal to my x plus 2. Okay, so now I'm going to need to move my x's to be on the same side, so I can subtract x here, so subtract 1x, and that should give me, I'm going to be left over with just this 0.261, so 0.261x plus 6.305 equals 2. So now I need to continue by subtracting my 6.03 or 6.305 to the other side from the 2 also. I kind of ran out of room, but I subtract it from there also, and that's going to leave me with the 0.261x equals 2 minus the negative, well, 2 minus 6.305 gives me negative 4.305. And then to finish, we need to divide by this 0.261. And my final answer should be negative 16. So x equals negative 16.49, so 0.5 really. So x equals negative 16.5. Alright? So hopefully you didn't get too lost in the decimal here, but it's the same process as I was doing before. Now what I'm going to do is actually show you another way of doing the same problem without this. It may or may not be easier for you, but let's check that out. And so it's without the circle pattern, but what you can do is, I call this superlogging because you can actually, when there's exponents on both sides, here, bases on both sides, you can actually just write log on both sides. Okay? And once you have it written as a log both sides, because if you write log on one side, you can write log on the other, you can actually take your exponents and move them out in front. So it turns out to be about the same amount of work, but we have x plus 2 in parentheses log 3 equals x plus 5 parentheses log 4. And so what you end up doing is having to divide by log 4 and we're in the same position as we were before. Or I guess we could have divided the log 3 and it would be the same fraction as I had before. So actually let's do that. Let's divide by log 3 so it looks like it did on the last problem. Okay, so now if I cross that out, you're looking at the exact same problem you were before. It's just another way of doing it. Okay, so I can still do the circle pattern, or I can do this log, dividing log on both sides. Okay, so on this particular problem, again, we can just do the same log circle pattern that I've been doing, or I can go ahead and write log on both sides. Personally, I like doing it the other way because it's a little bit less confusing with dividing the log, but whatever you decide. So I can take log base 4, okay, of this whole thing, 8 to the 3x plus 1 power equals 2x. Okay, and so now what I do is take this exponent, move it out in front, and I rewrite this to be 3x plus 1 log base 4 of 8 equals 2x. And then I do my little fraction bar and put log on the bottom and take my calculator and punch it in. And this turns into 1.5. And that's times my 3x plus 1 and equal to my 2x. So now I just need to take my 1.5 and distribute in here, and if I times that by 3x, it'll give me 4.5 x plus 1.5 times 1 is just 1.5 equals 2x. So now to continue solving, what I need to do is move my 1.5 to the other side, or subtract this 4.5. And I'll just subtract the 4.5 to make it a little quicker, save a step. So subtract 4.5 x from both sides. And if I do that, I'm going to get 1.5 equals negative 2.5 x. And then to finish, you just have to divide by negative 2.5. And then x is now by itself. X equals negative 0.6. So 0.6 if you will. Negative 0.6. Okay? So hopefully this one cleared it up for you if you were a little confused on the last problem. But I did, the circle pattern, and then moved the exponent out in front, and then continue to solve from there using the change of base formula. Okay?